Hello everyone, welcome to the tutorial video of rod cutting. In this problem, we have a rod of length n and an array prices of size n, where price of I denotes the value of a piece of length I, and our task is to determine the maximum possible value that we can achieve by cutting the rod of length n. So let's take the first example. The value of n is 8 and this is our price array. So the best way to cut the rod of length 8 is to cut it into two pieces of length 2 and length 6. So the value that we get is 5, which is corresponding to the rod of length 2, plus 17, which is corresponding to the rod of length 6. So 5 plus 17, 22, which is the maximum possible one. And in the second example, again the value of n is 8 and this is our price array, and the best way to cut the rod of length 8 is to cut it into 8 pieces of length 1. So the price that we get is 3 multiplied by 8, and here 3 is the price of a rod of length 1, and we have 8 pieces. So 8 multiplied by 3, which is 24, and the maximum possible one. So I hope the problem statement is clear to you. Now let's just move to the solution. So not only in this problem, when you have to maximize something or minimize something, then there can be only exist three possible solutions. The first one is greedy, then binary search, and dynamic programming or recursion. And it's always optimal to follow this hierarchy, because there might be a case when your binary search or dynamic programming solution requires some greedy observation. So it's always optimal to check for the greedy solution first, and greedy solution won't work here. And why is it so? So let's say the value of n is 3 and the prices that we have is 2, 5, 6. So if you greedily select the maximum value, then you will select 6. That is, we do not break the rod of length 3 anymore. But this is not the maximum possible one. The best way is to break the rod of length 3 into two pieces of length 1 plus 2. So the score that we get is 2 plus 5. And here 2 is corresponding to the rod of length 1 and 5 is corresponding to the rod of length 2. So the maximum possible score that we get is 7. So greedy solution won't work here. And also, I don't think that there exists some optimal strategy to find the check function in binary search solution. That is the answer. That is to check that whether we can achieve some particular score or not. Now we are only left with the dynamic programming approach, and the value of n can only be up to 1000. And let me show you this. So here the value of n can only be up to 1000. So let us start with some observations. So let me write the indices first. 0, or let's consider zero based indexing only. Then some index I, then j, then n minus 1. And let's define dp of I as the maximum possible score that we can achieve with the rod of length I. So it's very obvious to see that the indices which are greater than j will never contribute in my answer, because we cannot break the rod of length I into j such that j is greater than I. So what we will do, we iterate over all the possible values of I. So we iterate over all the possible values of I, starting from 1 to n. And for every I, we know the indices which are greater than or equal to I will never contribute in my answer. And why I am saying equal to? Because of zero based indexing. So I will simply iterate over all the values, let's say k, from 0 to less than I, or we can say I minus 1, and this I is denoting the length and K is denoting the index. So I will simply check that dp of I, that is what are the transitions we have. So we have an option to use the rod of length K. So dp of I is maximum of dp of I, and why maximum? Because our goal is to find the maximum value, comma dp of K. It's not actually K, but dp of I minus K plus 1. Because of the zero base indexing, the length of rod is K plus 1. So I will simply check that what is the best value to break the rod of length I minus K plus 1. And we already have this answer because we are iterating from left to right, that is the smallest value of I to the largest value of I. So we already have this answer. So why not to use this answer rather than computing this again and again, since this indicates that the problem having overlapping subproblem. That's why we are using the dynamic programming approach. So dp of I minus K plus 1 plus price of K, because we have used the rod of length K. So we get the price corresponding to the rod. So price of K. Alright, and after considering all the values of I from 1 to n, and for every value of I, we iterate over all the indices in its left and find the optimal score for rod of length I. And our answer is simply dp of n. But what would be our base case? So for the length of rod, for the length of rod 0, we do not get any score because we cannot break it further. So dp of 0 is equal to 0. So this was all about the explanation and observation. Now let's see how we implement this solution. So here this cut rod method is given to us, which takes the 2 parameter array price and the size of this array price. So we declare our dp array, so int dp of size n plus 1 because of zero base indexing. Then we initialize all the elements with 0, and dp of 0 is equal to 0, but since we have initialized all the elements with the 0, so we don't need this. Let me write over here. So dp of I minus I is equal to 1 to n, and here I is denoting the length, and then for every I will iterate over all the possible values of K, that is starting from K is equal to 0 while K is less than I, then K plus plus, and dp of I is equal to maximum of dp of I comma dp of I minus K plus 1, because K plus 1 is the length of rod at index K. Here this is nothing but index plus, and since we have used the rod of length K, so we get the score price of K, and after that I will simply return dp of n. Now let's just try to submit this. Okay, compiled successfully. Okay, accepted. And what about the time complexity? So the time complexity is quadratic, that is n square, and the space complexity is linear,